Purposeful Nudge introduces future-proofing enterprise AI operations. This will drive change in the field operations.
This is the financial reality behind the current AI boom. In 2025, OpenAI alone booked an operating loss of $21 billion against just $13 billion in revenue. Every token you currently use is being subsidized by venture capital and cloud giants who are pricing their services below cost to win market share. That gap is already starting to close. As providers move to usage-based billing to cover their infrastructure costs, high-reasoning workflows are seeing massive price corrections. Microsoft Copilot, for instance, has seen costs for specific premium model integrations surge by over 600%. To protect your margins, you need a blueprint to migrate processing from the cloud to local enterprise desktops. We are going to walk through how to audit your current risk, navigate the global hardware shortage, and restructure your IT field services to support localized compute. Preparing your infrastructure now is the only way to insulate your budget before the industry-wide shift away from subsidized flat-rate pricing is complete. Begin by auditing your existing software contracts for hidden exposure. Review all SaaS and enterprise platforms, like your CRM or ERP, to identify where AI functionality is currently embedded. Note the difference between simple manual prompts and agentic AI. While a single chat uses a predictable amount of tokens, autonomous agents run continuous multi-step loops that can multiply your data consumption and billing volume by orders of magnitude. Model a true cost forecast for these dependencies over the next 24 months. You must assume your current flat rate or bundled pricing will be replaced by metered, usage-based billing as vendors look to recover their margins. Unmanaged cloud AI consumption creates a volatile, uncapped financial liability that requires a rigorous internal audit. Step 2 is establishing procurement standards for AI PCs. These machines are equipped with neural processing units, or NPUs, which are specialized chips capable of running billions of operations per second dedicated solely to AI workloads. Localizing these tasks means your data stays within the hardware itself. This eliminates the latency of sending information to a remote server and removes the recurring per-token costs of cloud inference. Contrast this with the centralized cloud compute model. These massive hyperscaler facilities require enormous power and cooling, and their rapid expansion is creating a bottleneck in the global supply chain. The Stargate project and other hyperscaler buildouts are projected to consume 40% of global DRAM output. This unprecedented demand for memory is creating a physical shortage of the raw wafers needed for enterprise hardware. Because it takes at least 3 years to build and activate new memory manufacturing facilities, experts don't expect supplies to stabilize until late 2027 or 2028. Secure your AI-ready hardware now, or you may be forced to rely on expensive cloud services for years while waiting for procurement lines to clear. Step 3 is managing the hardware lifecycle. The high performance and thermal stress required by AI software have permanently shortened the business laptop's useful lifespan to just 3 or 4 years. You also face a hard deadline in October 2025. This is when support for Windows 10 ends, and keeping old hardware in service will trigger annual security update fees that double every 12 months. To fund your transition, implement a structured reverse logistics pipeline. Retired devices move through a disciplined workflow of retrieval, data destruction, and grading. Routing these machines to the secondary market captures their residual value, generating capital applied directly to your new AI-ready fleet. Reframe your reverse logistics from a simple disposal task into a critical funding strategy. Capturing that secondary market value is how you finance a rapid hardware refresh. Step 4 is modernizing your IT field staff. Moving AI to the edge does not eliminate the need for management. It shifts the focus to a human stability layer that ensures these systems remain operational and secure. Your technicians will transition from basic break-fix roles to adoption enablers. Their work shifts to configuring local hardware and ensuring the complex edge technologies are integrated correctly with your end users' specific workflows. These staff members also act as stability architects. They are responsible for setting the boundaries of local AI agents, auditing their file permissions, and managing the security patches that keep edge models protected. As embedded AI begins to handle routine tasks like automated scheduling and basic troubleshooting, your human technicians are freed to handle more complex, strategic issues that require expert judgment. As automation removes the administrative noise for your technicians, their role becomes grounding the digital system in reality, calibrating sensors, troubleshooting edge hardware, and maintaining the clean field data that AI systems need to function. This split-screen comparison shows your potential future. On the left, you're vulnerable to the volatile, rising invoices of cloud-based tokens. On the right, you have the predictability of a flat-rate budget based on hardware you own and control. By combining localized compute with a modernized IT field service team, you ensure your technology remains an asset rather than a liability. Take action now. Update your asset inventory, model your recovery value through reverse logistics, and secure your NPU-equipped hardware before the memory shortage worsens. Executing this blueprint today insulates your enterprise from the coming AI cost shocks and turns a global hardware crisis into your most significant competitive advantage.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.